Hello everyone, I'm Anderson. I'm delighted to have this opportunity today to share insight on product security. Our topic is No Product Security, No Business. With emerging trend on the horizon, how should the enterprise respond? I'm currently working at Delta Electronics as a product security service manager and the head of Delta Product Security Assessment Lab. In addition to hold multiple professional security certificates, I was honored with a contribution award for my work on SEMI E187 standard. I also served as a member of Taiwan Top Security Lab Committee, where I assist in developing security laboratory requirements, and as a member of Taiwan IPA Cybersecurity Talent Examining Committee. With over 20 years of experience in security field, I have worked extensively with various security standards and have helped multiple devices achieve compliance, such as IEC 62443, ISO 21434, FIPS 140-2, and common criteria. The future trend will be no product security, no business. So here is our today's agenda. Why does product security matter? Product security regulations and the Delta Electronics experience in product security. Key product security capability for product provider. Then we will have a takeaway conclusion. How does product security matter? There are three driving factors for product security. The first one is policy change. Starting from 2025, governments in EU, UK, and the US are setting more strict cybersecurity requirements for critical infrastructure in the industrial as electronics. These regulations are pushing vendors and the suppliers to adopt higher standards for product security to mitigate risk associated with cyber threats. Second one is demand for secure product. As insecure design and poor cybersecurity measures leaves companies exposed to supply chain attack. There is a rising demand for robust security solution for product. The supply chain is also an issue. One single vulnerable component or an embedded backdoor can compromise the entire security procedure of a product, making the supply chain a prime target for cybercriminals. We attempt to list the type of threats that are currently real and exploitable. First one is ransomware attack. And the second one is supply chain attack. The third one is OT device vulnerability. The last one is software update incident. The increasing diversity of attack method is causing operational losses for field owners. For example, vulnerability in legacy industrial protocols, which often lack robustness or authentication and encryption mechanism. A large number of devices run outdated firmware or operation system without timely security patch updates. So one key factor is that the equipment provided by product providers is not secure enough, becoming a loophole in cybersecurity. Due to the growing trends of attack and threats, legacy systems remain prevalent in OT field. To address vulnerabilities, field owners have been developing additional cybersecurity solutions. However, with the upcoming mandatory product security regulations, this approach is expected to shift. In the future, the OT industry will increasingly adopt securely designed devices. Therefore, ICT product manufacturers should take the lead in the transformation and capitalize on emerging business opportunity. IT cybersecurity focuses on management information and automating business processes, led by CIO and developer. using transactional architectures and standard protocols. OT security ensures effective control of physical processes managed by engineers and operators, relying on real-time, event-driven systems with proprietary protocol. Product security guarantees the trustworthiness of products through their lifecycle, driven by product managers and R&D teams, following security by design principles. While IT favors frequent patching, OT finds its complexity, and the product security prioritizes minimizing routine updates while enabling rapid response to threats. In the future, product security will be core in security domain. We will talk about product security regulations. Product security is rapidly evolving from a best practice to a business necessity, driven by both regulation and industrial standards. IC 62443's role as a comprehensive framework makes it a solid foundation for companies look to ensure compliance across multiple regulations. Since it's referenced in various mandates like Taiwan EV Charger VPC, aligning with it can provide a strategic advantage. This increasing regulatory focus in the EU is expected, but semi-ERT is rising, especially with backing from TSMC. Signals that cybersecurity is becoming critical in the semiconductor space as well. As more industrial leaders and governments push for compliance, product security will no longer be an optional feature. It will be a fundamental business requirement. Our observation for product security regulations, the EU, consisting of multiple member states, has established unified product security regulations, creating a comprehensive framework. The upcoming REDDA, effective August 2025, requires that products with wireless communication capability, personal data processing, or financial transaction function undergo self-assessment by product providers to ensure security. The CRA Cyber Resilience Act, in force December 2027, expands these requirements to all products that process or store digital data, including software, hardware, and services. Companies should perform self-assessment or third-party evaluation and comply with CE mark, technical documentation, declaration of conformity, and customer guidance for custom clearance. Non-compliance will result in substantial fines. Product security is no longer optional. No product security, no business. The CIA established two key requirements. The first one is vulnerability management and reporting. Starting September 11, 2026, all digital products must implement vulnerability management mechanisms. Security vulnerabilities must receive an initial response within 24 hours, with mitigation recommendations provided within 72 hours. The second one is full CRA compliance. By December 2027, products must fully adapt to CRA standards, including secure product design, risk assessment, threat modeling, regular security evaluation, and the structured security process. This regulation aims to strengthen cybersecurity across the standard. Based on the CRA, we have outlined potential requirements, some of which may present significant challenges for product providers. For example, the requirement that products must be free of known exploitable vulnerabilities before being released to the market is extremely difficult to achieve in practice, possibly due to limitations in assessment tools. Moreover, the CRA mandated that devices must support automatic security updates, which may pose practical implementation challenges in certain environments. Addressing these challenges require close collaboration between experts and the product provider to development design that the best fit the products. Vulnerability management is another key focus of the CRA. Product providers must establish vulnerability management process and policies, with clear definition for response time to vulnerability reports. They are required to acknowledge the initial report within 24 hours and provide a mitigation plan within 72 hours, which present a significant challenge for product providers. Additionally, the CRA explicitly mandated that product provider provide a software bill of material upfront and manage it ongoing, securely distribute update for products, and so on. So enterprises should proactively prepare for these requirements as early as possible. From our perspective, leveraging the OT standard IEC 62443 and the IoT standard EN 303645 as a foundation can effectively guide the implementation and the adoption of security measures based on different risk levels of devices. This approach helps bridge the gap between product security and the regulatory requirements. By adopting this strategy, organizations can strike a balance between cost effectiveness and the cybersecurity risk management, while ensuring alignment with the cost principle of current regulations. However, it's important to note that different regulations may have varying functional requirements and specifications. Achieving compliance across multiple regulations is a complex professional challenge that demands expertise and professional planning. Taking these regulations and standards as examples, product provider must address two key aspects. The first one is countermeasure, and the second one is assurance, along with vulnerability reporting and the management process. In the early design phase, story modeling and risk assessment identify potential risks. Based on these findings, countermeasures are implemented to ensure regularity and compliance risk reduction, ultimately lowering attack potential. Furthermore, comprehensive security assessments and tests validate the effectiveness of security controls. Penetration tests and vulnerability tests detect both known and unknown threats, while endpoint security technologies strengthen product resilience against attacks, significantly enhancing the assurance level. We will share about Delta Electronics' experience in product security. We adopt the widely used V model in product development to isolate threat, the implementation of product security. This model encompasses the entire process from the concept stage to design, implementation, verification and validation, and finally the operation stage. First, the involvement of professional consultants and architects is essential throughout the product security development process. Their expertise spans the entire product lifecycle, ensuring that R&D teams have the necessary knowledge to comply with regulatory and industrial standards. Additional vulnerability management and the SBOM software bill of material requires dedicated tool support. To address this, we integrate management tools during the yearly design phase and generate a SBOM through source code or binary analysis for continuous tracking and management. This approach enables proactive detecting and rapid response to security issues during both product development and post-marketing maintenance, ensuring compliance with regulatory requirements. Furthermore, endpoint defense technology is another critical aspect, particularly in our focus areas of OT, operational technology, and critical infrastructures. These devices often have limited computing resources and are challenges to update. To strengthen anti-malware capability in such real environments, it is crucial to implement low computation defense technology that do not require frequent updates. Our whitelist technology is specifically designed to address these industrial requirements. Finally, regulatory compliance demands a comprehensive range of security assessment. We have established a full suite of cybersecurity evaluation capability and services, include TMRA and TARA, threat modeling and risk assessment, penetration test, vulnerability test, fast test, vulnerability response and reporting mechanism to support all product teams effectively. Delta's product security capabilities began in 2018 with the establishment of the Security Center to provide internal services. In 2019, a technical R&D team was formed with the Delta Research Center to develop endpoint protection technologies and tools. In 2020, the Product Security Organization was officially established, earning Taiwan's first IEC 62443-4-1 certifications. To meet customers' demands, an ISO 7025 cybersecurity testing lab was completed in 2022 and began offering services. In 2024, the Product Security Business Unit was officially launched to provide security-related services and solutions both internally and externally. We also have several IEC 62443 certifications. I try to list them in the QR code. You could try to scan and check. Okay? Our services span industrial automation, building automation, information and communication infrastructure, energy infrastructure, electric vehicle, and power system. So, I will show you about product security capability for product providers. Facing current trends and threats, we recommend that product provider develop capabilities across multiple dimensions. Besides the IEC 62443, there is another guideline for your reference. Based on the data from U.S. Department of Energy (DOE), enterprise should address the following 6 key areas: cybersecurity culture from organization, digital product awareness, engineering information control, interdependency evaluation, planned resilience with zero trust, supply chain cyber risk management. In addition to IEC 62443-4-2, which is specific different levels of security functions for devices, there are another guidelines offering high-level recommendations. According to data from U.S. Department of Energy (DOE), product security capabilities should focus on the following 6 key areas. The first one is active defense. Then design simplification, secure information technology, resilience layout difference, consequence-focused design, engineered controls. These principles are also highly valuable for reference. Based on the needs of product providers, we have built a comprehensive one-stop service to meet diverse customers' requirements. From compliance consulting, testing, software technologies, and security tools, we offer a complete range of solutions to fulfill customer requirements. Leveraging data expertise, we developed capabilities that align with real-world industrial demand, delivering practical and effective services. What sets us apart is our practical in-house experience, enabling us to offer design recommendations that truly align with the needs of product provider. Our solutions are not only cost-effective but also practical and executable, ensuring seamless implementation. At last, here comes our conclusion, and we are here to share industrial trends and our experience with you. Finally, we would like to highlight some key takeaways. Today, we have 4 key insights to help you gain a deeper understanding of product security. The first one is the OT industry needs more secure products, not just more security products. ICT product manufacturers should take the lead in driving this transformation. The second one is balancing design and organizational strategies. Technical defense and management strategies must evolve together to ensure comprehensive security across architectural design, supply chain management, and organizational culture. The third one is security by default, or we can say security by design. Minimize the attack surface from the design phase and ensure built-in security is very important. The next one is continuous improvement. As threat evolving, organizations must establish adaptive security strategy to maintain high-level product security throughout the entire life cycle. We hope this takeaway could help you to different thinking and more understanding for product security. Thank you all for your time today. I hope this session has provided you with valuable insights and inspiration. We will continue to strengthen our capabilities and deliver professional services. If you have any questions, would like to discuss related topics, or brainstorm ideas, please feel free to contact with us. I'm Anderson. Thank you again. Bye-bye.